Welcome to day 2 of describing location of a distribution. So today our focus is going to be on, I can describe what happens to the shape, center, and spread of a distribution when data is transformed, and I can describe the properties of a density curve. All right, so transforming data. So transforming converts the original observations from an original units of measurements to another scale. Transformations can affect the shape, center, and spread of a distribution. So for example, you measure the weights of the members of your AP Stats class to get the following results in pounds. And what we're looking for is to do one variable stats to find each of the following, the measures of center and the measures of spread. So in my calculator, I've already typed it in, but I want you to take a moment, type in all the information into list 1 so you can do a one variable stat like me. Okay, so if you need to pause for a second to do that, please feel free to do so. But otherwise, I am going to keep moving forward on my one variable stat. All right, and here we go. So when we're looking for all these things, remember we have mean, standard deviation, and then we start diving into all of the interquartile, or not interquartile range, the 5-number summaries down here at the bottom of the list. All right. So I'm going to go back and I'm going to write in all of these numbers. So my mean, so 145.416 repeating. My minimum value is 101, 125, 138, 170, 200. It says my standard deviation is about 30.25. Interquartile range, I can't exactly just see, but I can calculate by taking Q1 minus, or sorry, Q3 minus Q1, and I get 45. Okay, so looking at this, now what I want to do is transform this data. So you realize that everyone's clothes add to the calculated weight. So you decide to be more accurate, you just subtract a pound from each data point. Recalculate the statistics for the data. All right, so now I realize that these measurements are too heavy. Okay, so what I need to do is I need to go back to my calculator and I need to take a pound off of each of these. There's a really slick way that I can do this, okay? So scroll over to list 2, and basically what I want to do, I want to take all those values from list, all those values from list 1. Why is that not working? All the values from list 1, and I want to subtract 1 from each of them and then hit enter. So you can actually do manipulations on your calculator like this. Okay, it's really, really slick because now look what I can do. When I go back to do my one variable stat, notice the data that I'm looking for now is in list 2. Okay, that's what I want to perform my stats on this time. And let's calculate. So looking at this, let's go back and now let's compare these values to what I had originally, okay? So scrolling through all of these values, the mean is, 144.416 repeating. My minimum is 100. Quartile 1 is 124. Median is 137. Q3 is 169. My max is 199. My standard deviation, 30.25. Interquartile range, 169 minus 124. So 169 minus 124 is going to be 45. So let's compare all of these things now, okay? So recalculated this, subtracting one off from every data point. And what I'm noticing is the mean, min, Q1, median, Q3, and the max all decreased by 1 as well. Standard deviation and IQR were unaffected. So basically, if I'm just going to take a value and subtract off that same amount from all my data points, it changes all of the measures of center, or maybe measures of position is another accurate description, but the measure of spread, it doesn't change. It doesn't change how far those values are from each other. Okay, all it's doing is it's shifting them down a little bit, but they're all shifting together. All right, so something interesting. Now, let's look at this. You decide that the clothes don't make much difference, so you go back to the original data. However, you decide that you want the measurements in kilograms instead of pounds. Divide each data point by 2.2 and recalculate the statistics. All right, so now what we want to do, go back into stat. Now this time I'm going to make a third list, okay? And this time what it's telling me to do is go into list 1 again, but this time I'm going to divide it by 2.2, all right? And that's how I'm going to generate my list 3. So this is going to be all of the weights in kilograms now, or instead of pounds, okay? So, and in doing this, now I can go to stat, calculate one variable stat. This time the data I'm looking at is in my third list. And calculate. So now let's go and look at these values. Okay, so the mean is 66.098 about. The minimum is about 45.91. Q1 is about 56.82. Median is about 62.73. Q3 is about 77.27. Max is about 90.91. Standard deviation is about 13.75. Interquartile range is 77.27 minus 56.82 is about 20.45. All right, so now when we're looking at when you multiply or divide, now every measure was divided by that 2.2, okay? It scrunched all my numbers together, and in doing so, it divided the positions by the 2.2 as well. Everything was divided by that 2.2, okay? So that's the difference between when you're adding or subtracting from a set of data versus multiplying or dividing. And it is very important that you keep that straight, okay? Adding, subtracting does not change the measures of spread, but multiplying or dividing does, okay? And to summarize that, I have this little snippet right here for you. The effects of adding and subtracting, effects of multiplying or dividing. All right, so now let's look at a deeper example, okay? So looking at this, in 2010, taxi cabs in New York City charged an initial fee of $2.50 plus $2 per mile. In equation form, the fare is $2.50 plus 2 times the number of miles. At the end of the month, a businessman collects all of his taxi cab receipts and calculates some numerical summaries. The mean fare he paid was 15.45, with a standard deviation of 10.2. What are the mean and standard deviation of the lengths of his cab rides in miles? All right, so let's take a look at this. So the fare that was paid, okay, had a mean of 15.45 and a standard deviation of 10.2. So if the mean fare he paid was 15.5 or 0.45, and this is the equation, so what that's telling me is to find the average length, the average miles he went. All you have to do is follow those operations, right? Take that 15.45, subtract the 2.5, and divide by 2. Okay, so according to that equation, on average, he went 6.475 miles. So basically, you had to subtract the 2.5 off and divide by the 2, as both would affect the mean. However, standard deviation, well, remember we already said standard deviation is not affected by addition or subtraction, right? So basically, that subtracting the 2.5, that wouldn't affect the 1020 at all. Okay, remember, addition and subtraction does not change. So that initial fee has no impact on the standard deviation. The only thing that does is when we divide it by 2. Oh, and I'm sorry, that should not be, that should be just 5.1. We're not talking about money anymore. So standard deviation, remember, it's only affected by multiplying and dividing, not adding or subtracting. So you would skip that step of subtracting the 2.5. So in terms of the length of the, in miles, mean of 6.475 and a standard deviation of 5.1. So in chapter 1, we developed a kit of graphical and numerical tools for describing distributions. Now let's add one more step after looking at this. And that step is sometimes the overall pattern of large numbers of observations is so regular we can describe it by a smooth curve. All right, so let's take a look at what that means to model with a smooth curve. Okay, so when I talk about a smooth curve, what I'm talking about is a density curve. Okay, and there's various density curves. In fact, the second section of this chapter is all about a very specific density curve. But in general, there's two things that must be true. They always have to be above the horizontal axis, and they have to have an area of exactly 1 underneath them. Such a curve describes the overall pattern of a distribution. The area under the curve or the interval is the values on the horizontal axis is proportional to all observations that fall in that interval. Okay, we'll talk more about that as well. So for example, the overall pattern of this histogram of scores of all 947 7th grade students in Indiana, the vocabulary part of the Iowa test of basic skills can be described by a smooth curve drawn on top of the bars. So notice you can take a histogram and kind of smooth it over, and that would be the density curve for that distribution, okay? So you can draw a density curve kind of over a histogram or something like that to get a sense of the smooth pattern that it makes. So for example, here are some patterns, and if we want the density curve, basically, we would just draw a smooth curve over the data. All right, so you can do that with any histogram. Again, But really it only works nicely when it kind of fits that smooth curve. It can't be super jagged and everywhere. Otherwise, the density curve wouldn't be an appropriate representation of it. Okay? Now, in density curves, the same rules apply to median and mean as they did back in chapter 1. So the tail is going to pull the mean and only slightly on the median. That doesn't change, okay? So histograms back then, density curves now follow those same rules, okay? So for example, this one, which is symmetric, the median and the mean are going to both lie in the center, okay? When it's symmetric, they're both going to be dead center. What about when it's pulling towards the right, when the tail is to the right? Well, remember, the mean is pulled more heavily than the median is, okay? And in this example, when the tail is off to the right, again, or sorry, off to the left, the mean is pulled greater than the median. Okay, so that general rule still applies in this case. So now let's look at a particular type of density curve. It's one that takes a constant height, so basically it looks just like a horizontal line. The density curve describes a variable whose values are distributed evenly or uniformly over some interval of values. We say such a variable has a uniform distribution. So let's take a look at what that means. So accidents on a level 5-mile bike path occur uniformly along the length of path. The figure below displays the density curve that describes the uniform distribution of accidents. So basically, along this 5 miles of path, you're equally likely to get into an accident anywhere along the path. All right. So first, let's explain why the curve satisfies the two requirements of a density curve. So first, is all above the horizontal axis. That was the first requirement. The second requirement was the area underneath it must equal 1, okay? Well, this one is easy to calculate that because the density curve basically just makes a rectangle. So length, which is 5, times width, which is 0.2, equals 1. So both conditions are satisfied. So, the proportion of accidents that occur in the first mile is the area under the density curve between 0 and 1. So the area is representing the proportion of the data that belongs in that region. So here, for this question, it's saying between 0 and 1 miles. Okay, so we're going to need the area of that chunk. Okay, so what proportion of accidents happen in that first mile? Well, the length is 1, width is 0.2, so 20% of accidents happen within that first stretch, okay, within that first mile. Zach's property adjoins a bike path between 0.8 and the 1.1 mile mark. What proportion of accidents happen in Zach's property? All right, so 0.8 would be about right here. 1.1 would be somewhere like this. So this one, we want the blue area, okay? So again, the proportion of accidents that happen is directly related to the area. It's the same as the area. So this time, the length is 0.3. All right, the height is 0.2. So this has a 0.06 or a 6% chance. So 6% of the accidents are going to be happening along his property line. Okay, so again, just keeping in mind the area under the curve is representing the amount of data that is in that region, the percent of the data that is in that area. All right. So again, that's going to be all for today. I thank you for joining me. And then make sure you ask any questions. Is there anything that you're still confused on?